Yeah, good day. My name is Sebastian Copei. I have the great honor to guide you through our next session. And let us start with our first talk, co-design of business and IT services. Please, the stage is yours.
Thank you very much. Thank you very much for having me here. My name is Blagovesta Pirelli. You can call me Betty, a little bit easier to address me. And I'm going to talk to you about co-design of business and IT services. That is a project that we've conducted with my advisor, Professor Alain Wegman, and two other colleagues, Natalia and Anton. And what do I want to address here in my talk? It's the problem that there is like a little bit of a discrepancy between the IT and the business world, and we have known about this for a while. And the biggest problem is like the level of abstractions that these two worlds are operating on. And the business requirements are often expressed in a very semi-formal or informal manner. And for example, if we are thinking about us as participants here, let's say, oh, I want to update my submission. I want to just put my camera ready on the website. And the IT specification actually will need something that is much more concrete and very well specified. So we cannot tolerate here ambiguity on like what does a camera ready mean, for example, or who am I? I'm the author ID and I have a string. And why don't we use some kind of like a modeling method so that we can actually have the language that is the same? Or even if it's not the same, that it's similar, and we can talk about the abstractions in a manner that we can understand each other. So the motivation of this designing services in this way is that the services are used both in business and IT, and we just understand services in a different way. And my motivation for doing it towards the OpenAPI approach is that a lot of those RESTful services nowadays are specified with the help of the OpenAPI specifications. So now it's about like how do we merge those two modeling methods or model-driven service design methods. And here I'm going to be working with the SIM method, which is a method that has been created in my lab at EPFL. And it comes from the enterprise architecture world, and you can see all of these levels that can kind of like represent the layers in an organization. So we have like segments and business, then we have like inside the marketing, then we have inside of the company, we have structures, and only down there there is some kind of technology. And we have like we have systems here that are cooperating with their services, that are contributing to a business process. And at the end of the day, we are just modeling a service which is contributed by a system. And the system can be the organization itself, but it can be actually down there, here, an application, a VM, or anything else. So the modeling process that I'm going to start with is the top-down approach. And we have already seen something which was a top-down model-driven approach towards service design. And what I'm going to go from is the service system models that we've seen just now as an example. We're going to annotate them with system properties that are going to be representing our data model in a very light way, without the constraints and without, for example, an ER model or anything that represents also relationships. Then we're going to put a little bit of the annotations for the REST APIs. And this is where the model diverges from what has previously been done. And then here we're just going to use a tool to do the model transformation, and then we don't have to do all of these things all over again. So I'm going to go with an example, and the first one is the first step for the modeling of modeling of the business process, which is going to be to understand the business environment at first, and then to model the service that is provided to the client. A client, if you're from the business world, think about the client as a client. If you're not from the business world, it's a user, someone who wants to use something that we provide. And we abstract the implementation details, which is what the definition of a service in both business and IT world mean. So here, we're going to take the example of an airplane manufacturer. It's a classical case that we use from practice in the teaching courses in the courses that we have. And here there is a small legend. We do have a hexagon as well, but it's a process. And here this is the Valley network. This is the business unit that is providing the service to our client. There is an airplane club who manages airplanes, and sometimes these airplanes, they break, and they need someone to repair these airplanes. And when they break, sometimes it's the engine. And then it's at this point, we have to manage all of the complexity of ordering a part, getting everyone to agree who needs what inside of this little box. But the airplane club does not see that. This is the interface where they receive the service of the airplane maintenance. So business case, nothing too much. Now we're going to go inside of the service model, and we're going to look into the internal organization of the provider. So the value network has different actors who are going to be now seen in a white box view. And it's hierarchical, and we stay with the same notation, so we don't have to change, and we don't have to go and invent more and more notations to express the internals of an organization. So now we have like the engine manufacturer who provides spare parts. We have some kind of a repair shop, some garage, someone who actually takes those parts and puts them inside of the airplane. And then we have certified technicians. We have people who already know how to do stuff. Again, we continue, and we now want to know how people are communicating. What is it that they're doing on a daily basis? And this is going to represent what kind of information they're handling. And this is where our data model is going to come from. And now when we get into like model the information of the actors, we can actually do it with the domain-driven design. We can go and extract in different ways the concepts that people are using daily so that we can annotate additionally the models. And then we continue. We have part certifications, repair of airplanes. So we have additional properties here that we annotated. All of this is a graphical representation of a meta model that has already been established for a while. It has been formalized. So these are things that are used with certain relationships between themselves. We can use also pre and post conditions here to express, for example, what the part is gonna what is gonna happen to the part, what is gonna happen to the engine, and it's a declarative way of expressing the world. So we don't say how we're gonna do it. We know what is the state when we're expressing this reality in the model. So now, this is where we're going to push a little bit further down. Yeah, so we are going to push a little bit further down the abstraction levels, and we're going to go for the web services. All of these people who are talking about repairs and engines and everything else, their information systems sitting somewhere. And these information systems are drilling into our presentation. These information systems contain this information, and sometimes we need to work on the information. So, at the end of the day, I'm just gonna check, okay, this airplane, this repair, and all of these things, we need to actually create the repair request. We need to do basically the CRUD operations. We need to create, read, update, delete. We have to just operate on very basic operations on our data. So, in order for me to manage my airplane, and to receive this airplane maintenance, I need to be able to repair, to create the repair request, to read what is happening with my requests, to update them, and I continue doing that. Ooh. I'm sorry. I think that I've skipped a little bit too much. I need to specify now a little bit more in details what the request is going to look like. So instead of just like saying, okay, I have a read, delete, and update, I'm going to say, okay, but this is not only that. I have an information that is actually represented in a new repair request, and I'm going to start discussing with my clients. Here again, we're trying to build a bridge between the information systems people and the business people and the service providers who are working on an information. So now I can go and actually ask them, so when you're creating a repair request, what is it that you have in your possession? From your point of view, what do you need me to give you as an output? So here it's a negotiation tool as well, because we are going to be able to explicitly model with the help of the people who are going to be using this these services what exactly they're going to need from the contract. So it's also touches upon the design by contract mechanisms from a little bit further before our service-oriented architecture days. So here now we have like all of the information in the model. We're just going to run this tool that is going to generate the OpenAPI specification. And this is okay. Right now we have an OpenAPI specification that is correct, that can be run. And we have like the basic three parts of it. So we have the beginning, like the header of the OpenAPI spec. Then we have the paths that we have specified inside of, for example, this create a repair request has been done for the airplane club. And over there, we have the schemas or the objects that we're going to, the schemas for our definitions of objects that we're going to be exchanging between the services. So, yes, but we have to actually do it also the other way around. Because at the end of the day, not everyone is just creating services. A lot of people are just consuming those services. So we have to actually see what are these specifications that people already have in here. So can we actually take them and make a little bit more sense on the business side of things? So now we have all of the information that the information systems exposes as functionality, and we want to structure it so that we can embed a little bit more the context of the business use for these services. So what happened is that if we just take the OpenAPI specification and we generate the service model, we're going to come up with something like this. This actually loses the structure of who is our service provider, who is the value network, who is within the value network of the service provider, but we still have a bit of the logic of like what is this process of the airplane club, who are these people in here. We do have a little bit of the structure, but not too much. Everything is connected to only one process because we don't know about the structure, the hierarchical structure of white box, black box. So what would happen in a scenario like this is that we're going to start with a model like this, then we're going to change it. We're going to change the levels, and we're going to represent it in a way. It is a graphical tool. We can change it more or less very easily with the help of our cat tool. So after we change it, we're going to ask our business services to REST API 2 to generate more annotations in the OpenAPI spec. And by annotating, embedding this information inside of the OpenAPI spec, we're going to be able to preserve also the dependencies for the translation from the IT model to the business model. And at the end of the day, with these dependencies, we're going to arrive at precisely the same model, which for the brevity, I'm here just putting it into the white box view without the value network of the manufacturer. Okay, so that was it for what I had to present to you, but now I want to discuss a little bit about what are the implications of all of this. Why am I even talking about this? Like, who do services belong to? Are they IT services? Are they business services? Do we need to model them from the point of view of the person who is providing the service, as me, who is exposing services on my server? Or is this some service that is going to be inside of the adopter? Who is it that is using the service? And there are different services. There are infrastructural services, there are functional services, and they all have different, they all have different places. And how do we model this data? Because at the end of the day, the data is what drives the use of these services in the business case. So we need to be able to express the dependencies between the data. So the data model needs to be embedded. The data model needs to be communicated with the people who are going to be using our services. And model-driven anything, so why? Why do we even do model-driven engineering, architecture, development? How far can we push the boundaries of the model-driven engineering? And in my opinion, in here, what I'm advocating for is to make it explicit. Modeling is a way of making our assumptions explicit. Even if it's not used to generate code, even if it's not used to generate all of our infrastructure, the coordination of the services, we can still make it so that we are able to explain, this is what I'm doing for you, this is what kind of services I'm going to expose to you, and later on we are going to be able to communicate also to our developers what they need to be able to implement. It is not just, it is not enough to say, please implement a service that's gonna receive the camera readies of our participants. We need to give them the specifications. So the last point is that this approach is still a work in progress. So I'm looking forward to validate it with the community. That's why I'm here, to talk to you about what we have come up with. and also to apply it to a use case, to apply it to some other places, and to extend it further down into the modeling languages and different other abstraction levels. So that will be my presentation. Thank you very much, and I'm open for questions.
Yeah, thank you.
Thank
So,
you.
do we have any questions? He's the first.
Hello, and thank you for your presentation first. What's your experience? We did some graphical modeling, although some graphical representation of models too, and was a little bit difficult to identify the concepts when we got huge examples. So did you make the same experience?
Yeah. So yes, we applied this to a case that is actually a public access case for managing marketplace for datasets. And in that example, the requests and the data that was represented was too big. So in the graphical model where we saw the data over here, this was becoming like, this was impractical. And that's why the point of the discussion was like, how do we represent this data so that we can hide it a little bit when we need to hide it? And I agree with you that it becomes very messy very quickly if we don't contain the complexity of the graphical model. And that's why this is also a stepwise approach, and everything can be hidden. Like all of these things are collapsible boxes, because like people get confused very quickly if we present to them more than just a couple of boxes, basically. So yeah, very good point, and I agree with you.
Thank you.
Thank you very much for your presentation. Just a question, how do you model workflows?
That's a very good question.
Because inside the workflow, you know, data can be merged, can be separated, can be...
Yeah.
So
The workflow, I would not say problem, but the workflow challenge is that in here we're just doing declarative semantics. So it's like, okay, so this is what I'm gonna receive at the end of my service. Or if we just take the workflow of the value network, right now we're mapping it to BPMN, to just like have something that is already there instead of reinventing the workflows, or if we're talking about orchestration in the world of software service-oriented architecture instead of orchestration of containers. We just want to do workflows on this level and then map them to the services instead of doing it inside of the model again, because it's going to be too messy, and I believe it's infeasible for now.
Okay, thank you. We have time for one little question. Anyone? Okay, then please, thanks again.
Thank you.